Yeah. Well, I had things. Yeah, I don't know why I closed it. I normally don't, I don't know. Anywho, so you can go route A, the blue route, but you could also, if you wanted to, go from the number of particles A to the number of particles of B, and then convert that into moles. So you could take the blue route or you could take the green route, and it really doesn't matter. Yes? If it were me and I had to choose, I would probably go from the number of particles to moles and then to moles, just because it's more consistent with everything else I do, because I always convert to moles first, right? So mole ratio, particle ratio, they are identical. We have a 3:2 ratio, moles of H2 to moles of NH3, and a 3:2 ratio of molecules of H2 to molecules of NH3. Let's see if there's anything actually interesting in here past that. So actually, I'm going to just scroll down so my little map is covered. How many carbon dioxide molecules are produced when 0.76 moles of propane are consumed, combusted? So we would be starting with 0.76 moles. Which substance here is propane? Propane. C3H8. So we would be starting with 0.67 moles of C3H8, and we want to finish with the number of CO2 molecules. What is one direction we could go? What could we convert moles of C3H8 into? We could convert that into moles of CO2, and from there we could convert that into CO2 molecules. Or the other route we could take, 0.76 moles CO2, what could we convert it into? Or no, sorry, C3H8. We could do the number of, particles of C3H8, and from there we could go to the number of CO2 molecules. I don't know that there's anything here that like is really super exciting, right? Like that's just, I don't know. If you want to see the math, here it is. Woo, look at that. Ooh, look, we cancel moles and we find moles, so we use our mole ratio here. And then don't forget the 6.02 times 10 to the 23 goes with the molecules, not with the moles. Don't ever write 6.02 times 10 to the 23 moles. That would be wrong, okay? Never. Not that I could, okay, never's a strong word. I could give you a mole of moles, okay, but that seems unlikely, yes? It is unlikely I will give you a mole of moles. Do you guys just want to try a few of these? Or do you want me to actually go through an example? Why don't you just try some? Like go to page, where are we? Ah, so much writing for like nothing. Oh my God. What on earth is happening here? Lordy, lordy. Okay. Do you know what you could do? You could just go back here to page 31. I feel like I'm flogging a dead horse on the pages before that. And you don't necessarily have to do this part. Do you know what I mean? Like that's kind of like optional. You could just go to the meat of the question, which is solve the problem. If it helps you to do the known, the unknown, and the map, that's great. but if not, you can just solve the problem. So page 31. Try a few. Are we good? Okay, cool. So this bit here, just to clarify, this is optional. You can go straight to solve the problem if you want to. Okay, and again, we are on page 31.
You think it's disgusting? Why would you show it to me? No. Easily. So all your work. What do you do? Give us like a compound that might, like you'll give us like what you like let's say synthesis or something. If you give us a compound that might have no reaction. Not when you're like studying. Alright. So you pass down a reaction to say how much of this will get used up when it reacts rate. Yeah, I know what you mean though. You know, fast often induces immune systems weaken response. So it causes them to be sick. Yeah. I know you have nothing to do with it. Just so you know, in this class, if you are away on the day of a test, that happens. If you're on the way on the day of two tests, then I start to wonder. And if you're away on the third test,
then you get a harder version than everybody else in a limited amount of time.
That's better for the exam.
Yes. So yeah, you would have to redo the mole test. All your future tests would be like the mole test. Not long, but with limited time. If you skip my tests. And I know there's some of you out there, your parents will lie for you, which if your parents will lie for you, you really need to think about your family values, I feel. That's just a personal thing, but you know. Yeah.
I will be here for the quiz.
Okay, that's all good. Quizzes are a little bit different. Quizzes are like you got to retake them and stuff, but like I know that, and especially in grade 12, there's like the exam flu. You know what I mean? Like people are like, oh, I'm away. Oh, it's another test. Oh, I'm away. I had a boy who was away. I'm 12. Every quiz day, every test day, always away.
That's what I mean. Like I figured it out. Daniel, I think it gets anyone else in class.
Like if you ask me, would you do it for $1,000,000? I'd rather do this.
Are we done question 2? Or are we working on question 2? Okay. Do I have Kleenex? I have toilet paper. I know it looks ratty, but that's just because it never gets used and just gets stuffed in the drawer. It's better than like the paper towel is your other option. I need to bring in tissues. You're welcome. It's sort of my little emergency backup.
I mean, it's better than that. That really hurts.
That's what I feel, and I don't know. Just this year, I haven't had it here. I don't know why. Are we ready to move on in 5 minutes? Okay, 5 minutes. We're moving on.
How am I going to make the dimensions of come on?
Oh no. Sorry.
No, wait, no. Just do this.
to move on? Okay, page 33. Gas stoichiometry. So the only reason this really deserves its own little section is that what do you remember about equal volumes of gases? Equal volumes of gases, what? Yes. At same temperature and pressure, yeah. Yes. And the nice thing about that is it means if you want to go from a volume of gas A to a volume of gas B, you can actually use the same ratio as the mole ratio, right? Because the volumes will contain equivalent numbers of particles. And if this is like, I don't understand why that is, we're going to take a little look and maybe this will help. I hope it does. So if we have the equation N2 plus 3H2 gives 2 NH3, that means we have one molecule, of course, of the N2 reacts with 3 molecules of the H2 to give 2 molecules of the NH3. We can do that same ratio, a 1 to 3 to 2 ratio with moles, but it also works out because 1 mole takes up 22.4 liters of space, right? So 3 is going to take up 3 times that much. So once again, so if we look and we calculate that out, that is 67.2 liters, which is a 1 to 3 to 2 ratio for the volumes. So you don't actually have to go through the mole if you're going directly from volume to volume. You can take a shortcut and just go straight there using the same ratio. Okay, so you could, if you wanted to, if we take this equation where we have a 1 to 3 to 2 ratio, we could do it in the normal way, and we can convert to moles first and then to moles of our unknown, and then do that. So we could go, here's our liters of N2, we convert to moles of N2 to moles of NH3 to liters of NH3. And remember, what's the conversion? Is it 22.4 moles per liter or 22.4 liters per mole? 22.4 liters per mole. Make sure you put the 22.4 in the right place. You can do that, but what you'll notice is that this conversion factor is the exact opposite of that conversion factor. So you're just converting in and out of liters, right? So you can simplify that, and instead of going through the 3 steps, you can use the same ratio, the 2 to 1 ratio, for just volume to volume. And so instead of taking 3 conversion steps, you can do it in 1 conversion step. And it is only because the gases take up, 1 mole of gas takes up exactly the same amount of space no matter which gas it is. Yeah? This shortcut works only for converting from liters to liters, but it sure is handy if you know what you're doing. Okay? Now, do not mix up volume of a gas with volume of a solution. Don't use 22.4 liters if you're dealing with a solution, right? So make sure you're looking at your substances and using your brain, right? So you're going to look and say, what volume of CO2? Oh, that's a gas. So I am going to be using, 22.4 liters. Okay, but in my second part, 1.25 liters of 0.55 molar HCl. Remember, what does it tell you when you see molar? That tells you you have moles per liter, but also that you have a solution. Okay? So do not be using 22.4 liters when you are given a molarity. In this particular question, who is the known and who is the unknown? HCl is the known, and our unknown is the CO2. So I think at this point you guys are good at finding moles of HCl. Am I correct? You want, yeah, you're gonna try it? Or we're good? We're good, okay. So we will take our liters of HCl and use the moles per liter of HCl given in the question. Use your mole ratio to get from HCl to CO2. And then finally, because CO2 is a gas, that's when you use your 22.4 liters. Okay? So whenever you are asked for a volume, be sure to check, am I looking for a volume of a solution or am I looking for a volume of a gas? And make sure you're using the correct conversion factor. I think that's really the only thing that's a little tricky here. So just try a few of these to make sure you're on the right track. Okay. What's that? Oh.
Yeah, bro.
It matches your shirt too. It could like camouflage. Right? Oh,
Let's see that.
yes, we all want you to do it right now. Yes. Here we go.
All of these songs. Tuesday. I am like that.
So folks, there's a problem on the answer key on page 10, number 2B. Is that number 3? No, it's number 2. A 6-to-3 ratio. Oh my God, then I'm even wronger. Hang on. So this number won't be right. There we go. That's better. Yeah, I'll be right there. Just gonna go, nah. Okay. Yes. Oh, it should be 0.40. Yeah, so that's page 11, number.
Ball.
Yeah.
Oh, this is how we get balls. Sir, this was the earn subject. Yeah, these were subject from before the anyway. So this is McDonald's. No, I said no. Yes. So you've got two traditions of ideas and infinities, and then you've got like positive negative attributes. All it's do is just it was a quiz. One of the quizzes that was like key chart with four and there's lists of words. It's like you check your mind. Oh yeah, I want to find. You have like one that you like and one that you don't like. That's your submissive dominant.
Oh,
Two.
right.
Okay.
So one that's more powerful.
Yeah.
I
How's your
don't
project going?
not good. I would. Yeah. I know. Sort of. I will be honest. I cannot find. We look up some dominant. That's not exactly bad. It's not that at all. So I had to. I in order to get the version of that, I had to go onto like that internet archive thing on the website. It's like straight HTML with no CSS. But if you look at key types, only one I can find. I was shocked. A lot of days. I spent like 30 minutes.
What page was that, Devashri?
My only problem with this, not here to promote these practices. So what I'm gonna actually do is I'm gonna take this test.
Hi.
Should we know that?
No. That's why I gave you the formula. Hi.
If you give us like point or 500 milliliters in a question,
Yeah.
do we have to show that we're changing it to 1,000? Like,
You don't have to
liters?
show the conversion, you can just move the decimal.
Okay.
Yeah. to move on, or do we want 5 more minutes? 5 more minutes? Is that enough? Is 5 enough? Okay, 5 more minutes.
Grilled cheese sandwich. I need to go. There's a lot of extra stuff. It's not just salt for it. There's a lot of extra No, the idea is I can show it. It's a report. The idea is just a report being given and shared with the parents. Yeah, I'm playing into it. Read the first line of the assignment. For the assignment, you will assume the role of assignment. Bam. Question. I'm kids. I'm assuming this going to their parents. That's a logical. Yeah, my where are you going? Never, okay, never mind. His main complaint is that his mom likes it. His mom and his dad both like to make appointments without him knowing any individual's role for some reason. Even though they both really care about making academic things, I think they're just confident, in Nathan's academic skills that it's just fine.
What section is that in what book? 6.4 in here. And you guys know that, did I put it in here? Let's make sure I did, because sometimes I think I've put things in and I haven't. Oh, maybe I haven't. Oh, that's not us. That's chemistry 11. That would be why it's not there. Let's hope it's in ours. Let's go see. Upcoming quizzes and tests. Oh, it's not there. Okay, so let's go to homework and see if I put it there. Oh, I put it in general. Oh, that kills me. Okay. Yep. Okay, so is it? Did I? It's under homework. Okay, so I've just totally randomly put things places. Yeah, here we go. I will put this also in, no, hang on. Yeah, review for the quiz on Wednesday. There we go. Copy that and we'll stick it in the upcoming quizzes and tests as well. New conversation. There we go. Yeah, so just 6.4. No, not the bonding, just 6.4. Okay. Yes. No, not really. I mean, there's only so many ways to ask those questions. Do you know what I mean? Like, if I make up more, they will simply be the same questions with different numbers. And you can do that for yourself. You can be like, okay, I'm just gonna, yeah. And so if you want to do it like from scratch on Teams, there's of course like the blank one, so you don't have to have things written on it. So if you just want to do them again. Does that make sense? Yeah. Yeah, I looked into it and I'm like, I'll just be writing the same questions again with different like numbers. So it seemed a little pointless. Okay, we are on page, except for I think this thing is having a little bit of a fit, as it is wont to do. So maybe you get another minute while I close it and open it again. No, we're gonna leave that. Okay, we're leaving that for another day closer to the test. Ah, here we go. This looks much better. All right. We are on page close to 40. We're on page 41. So we are going to make the most simple sandwich that you have ever made in your life. We are going to use 2 slices of bread and 1 slice of cheese, and we're going to make one sandwich. And you'll notice that the cheese isn't in between the bread. That's so that you could see it. Okay, technically, the other bread should be on the top. All right. Yes, we're good with that. All right. And just so you're also aware, if you're like, I'm not getting it with the cheese and the bread, Ms. Spence, you can go see Paul Anderson, Bozeman Science, doing a little video. Okay, so that's just optional if you want to. Now, let's say I gave you 3 slices of cheese and as much bread as you could ever want. How many sandwiches could you make? 3. Oh, so hard, right? Given 4 slices of bread and an unlimited supply of cheese, how many sandwiches could you make? 2. So now let's assume that I give you 3 slices of cheese and 4 slices of bread. How many sandwiches can I make? 2 sandwiches. Which substance is limiting the number of sandwiches? The bread. So the whole point behind this limiting reactant thing is that you can determine, even if you have extra of one substance, you can determine what is the maximum you can make if you use up all of one of the substances. You say, how much product can I make from substance A? How much product can I make from substance B? What's the smaller amount of product? Whichever A or B made the smaller amount of product, that's the one that limits the amount of product that can be made. Yes? So even if I gave you more bread, more cheese, I could not use the cheese. It would just simply be left over, right? Oh, by the way, how much cheese would be left over? 1, because you know that 2 of them get used up making the 2 sandwiches, right? So if you can figure out the amount that's used up, you subtract it from the original amount, you can find the amount that is left over. There's a little picture, just in case you didn't follow that. Okay. This is where we learn some terminology. The bread limits the amount of sandwiches that can be made, and that is why we call it the limiting reactant, which we will often abbreviate as LR. Okay? You will also hear it referred to as the limiting reagent. Reagent and reactant just mean the same thing. Okay? There is excess cheese left over at the end of the reaction, and therefore we call it the excess reactant. And I will often abbreviate this is not an official one, as excess. Yes, XS, excess. No. See, when I grew up in the 80s, there was a band called In Excess, and they spelled their name in excess. So it was more fun back then. But now it's just excess and nobody knows the band, so it's like whatever. I don't really remember. Like, I don't think they were one of my favorites. So, I mean, you could look them up. I'm sure they were very popular at the time. You might be able to find something. Yeah. All right. Consider the following balanced reaction. We have the little square thing with a notch. We have a triangle, and we make a square thing with a notch attached to a triangle. If I give you 4 triangles and one of those square things with a notch, what would we have after our reaction? Please draw it. Is good. Which reactant is the limiting reactant? The square thing, that is our limiting reactant. And the green triangles are our excess reactant. How much of the triangles are in excess? 3. We have 3 triangles in excess. Okay, here's the picture before and after if you were not wanting to draw it. Which substance is limiting? This one. Which substance is excess? There we go. Given 4 triangles, you could make 4 product, yes? Given 1 square, you can only make 1. So basically, all of this is just to say that to find out how much product you actually can make, you have to find out 2 amounts. You find the amount of product that could be produced by each reactant. So you're basically finding the amount of product twice, okay? So you'll find the amount of product from A and you'll find the amount of product from B. And you'll say, which one is smaller? The smaller one is how much will be produced. And that is called the theoretical yield. The word yield means how much you get. It's not the kind of yield that you learn on your driving test. Okay, different kind of yield. Yield means how much is produced. So we say, oh, from reactant A, I could make 4 moles of product. From reactant B, I could make 5 moles of product. How much product could I actually make? What? From reactant A, I could make a maximum of 4 moles. From reactant B, I could make a maximum of 5 moles. How much can I get? 4. Yes. Okay? Now, why is it called the theoretical yield? It's because if you were to actually go and do the experiment, how perfect do you think reactions are in everyday life? They're not actually perfect. Sometimes you can end up with like side reactions happening, and that actually decreases the amount of product. Sometimes you might collect the product on a piece of filter paper, and then you have to scrape it off the filter paper. And some of it gets left behind on the filter paper. So the amount you get is not actually the amount that you predicted you would get. That's why we call the calculated amount the theoretical yield, because it's how much you could get maximum in theory, okay? So, you know, when you're in university and you're doing an organic chemistry lab and you do like all these 7,000 different steps to synthesize a product, you might end up with only a 75% yield, right? Because your theoretical yield would be like 100, but you only got 75 grams, and so you would have a 75% like actual yield. All right. Do you guys think you could work through this? Actually, do you want to just study for your quiz for homework? Yeah? Okay. Shall we just work through this for the last 5 minutes? Get through it? Yes, you have a question. Molar conversions, yes. Mole ratios, yes. You can simplify the fractions. It's often just not done because, you know, we're lazy, and that would require an extra step of thinking. But if you're happy to think about it, then go for it. Yeah? Yes? Of course. Okay, example number 3. We only have 5 minutes left, so give me your absolute focus for 5 minutes, and then you're on your own. There's no homework other than studying for your quiz, okay? Here's our reaction. 2H2O, 1O2, 2H2O. If I have 6 moles of the H2, how many moles of H2O can be formed? You should be able to just look at it and tell. 6, right? Because I have a 2 here and I have a 2 here, so it should be the same. If I react 2, I get 2. So if I react 6, I get 6. If I react 4 moles of O2, how much H2O will we get? 8, because there's 2 waters produced for every 1 O2. So we would get 8 moles of H2O. So now if we take 6 moles of H2 with our 4 moles of O2, how many moles of H2O can be formed? 6. We just choose the lower number, yes? Which of the 2 reactants was the limiting reactant? The H was the limiting reactant. It's the one that produced the smaller amount. Which reactant is in excess? That would be your O2 because it produced the bigger amount. Was that a question or a stretch? Stretch, cool. And this is just kind of here because sometimes people think, oh, I have less O2 than I do H2, so that must be my limiting reactant. But you have to remember, of course, you need to use twice as much of one as you do of the other, so that factors in there. I think that's a more important question when you have people who don't have like the natural mathematical reasoning, which I think most of you do. Yeah, and that's it. We'll just leave it there for today. Okay.
Can I leave Armin's water bottle here?
Yeah, and we can put like a little note. Yeah.